What we have here is we are looking to solve equations, and these two are involving exponential functions. Now, these are some very common exponential functions or exponential equations that a lot of students have some trouble on. So I hope this tutorial will help you understand how to do these a little bit better. First off, whenever you're given an exponential like equation or one that has exponentials in it, when you're solving it, you have to kind of identify what type of it is. Now, normally this is not a normal easy exponential. For example, an easy exponential equation would be if we had 3e to the, I'll just even make it 4x equals 7. All right. If we were to solve one like this, it's pretty easy to solve for x. All right. In that you have to first get the exponential by itself, so you have to divide by 3. So we have e to the 4x equals 7/3. And then you get the exponential, now you go to log it. So when you natural log both sides, you have the natural log of 7/3. These will cancel out. Using inverse property, you have 4x equals the natural log of the quantity 7/3. And then you're going to divide by 4. So you have x equals 1/4 times the natural log of 7/3. Okay, and most students understand that. That's not too bad. Um, they get that. However, you throw in one where you have two different exponentials. How do you solve something like this? And a constant. Well, this is a special case. When you have one like this, in this special case, you have to understand that you have e to the 2x minus 7e to e to the x plus 12 equals 2. This is actually what is known as quadratic form, quad form. In that, e to the x is actually being squared. Using the private exponents, I can rewrite this as e to the x squared, because when you have an exponent outside, you can distribute it through, and we have that. We have minus 7 e to the x, and I'm just going to subtract that to the other side, so I have plus 10 equals 0, just to kind of simplify it a little bit. Now, normally, this doesn't look like a normal exponential. However, if you think about it, if an exponential form is where we have ax squared plus bx plus c, that is a quadratic form, okay, quadratic form. Well, what is our base? Well, in this case, we have a coefficient of 1, but instead of having x, we actually have e to the x. So what we're going to be looking to do is, if you think about this, and you just put, like, instead of having e to the x, let's just think that e to the x is actually equal to what, like a letter u. So for all e to the x, I'm going to plug u in there. 7u plus 10 equals 0. Now, if I gave you this, I said, okay, solve for u. Well, hopefully it was like, oh, that's quadratic. Let's see if I can factor this. So I got minus 5. I have u minus 2. That equals 0. And what we have is u equals 5 and u equals 2. And that would be our answer. That's pretty easy. Well, the thing is that we're going to do the same thing, except instead of putting u, we're actually using e to the x. So essentially what we have then is, instead of having u, if we just kept the e to the x there, we could just put e to the x. We could have put e to the x. And this right here is going to be e to the x and e to the x when we solve it. Well, now how do you solve, what does the exponent have to be in order to get 5? Well, x has to equal the natural log of 5 in this case then. Right here, instead of having this, we're going to have, what does x have to be in order to get 2? Well, x is going to have to equal the natural log of 2 in order to get that 2 that we need to get that. And right here then is going to be our answers. So whenever you have an exponential like equation with three different terms, one thing you might want to always check out is it in quadratic form? And just to show you this, illustrate this one more time, I have another one just very similar to this. So if you want to try this one out, you can pause this and then see what the answer, see if you get the right answer. All right, so once again, we have e to the x squared, and we have 6 e to the x plus 8 equals 0. Well, we can make it u like we did over here. Or if you can figure it out, it's going to be e to the x. See if you can factor out 8. Does any of that equal 6? I believe 4 and 2 is. So we go e to the x minus 2 equals 0. So what do we got here? Well, natural log x has to equal natural log of 4 and the natural log of 2 again. There are our two solutions. So there you have it. Special cases, some more difficult, harder problems, but ones that are in what we refer to as quadratic form. And this is how you can solve equations of exponentials. All right. Well, I hope this helps you out. Good luck and God bless in the rest of your problems.